Yo, Unit 5, Skill 6. Thank you for doing the Unit 5, Skill 6 video. Anyways, how do we solve radical equations with square roots on both sides? So these are the harder radical equations. Definitely makes you do some work with it. So, first question we have is, well, what are we going to be doing here? Well, we do have to square both sides, that's the idea, but the first step that we normally had was isolate the radical, and that's kind of impossible to do. So, because of that, we have to just square both sides and deal with what comes up. So, I'm first going to add the 1 over because I don't typically like to have a radical with a minus sign in it. That just throws everybody off. So I'm going to square both sides. And the left side works out to be real nice, and the right side works out to be, well, not real nice. So, left side again is just negative 2 minus 6p. The right hand side, we have to FOIL it out, so we are going to have to write small to get this to fit in here. I probably won't be able to, simply because I have to write like Gigantor on this thing. Alright, so we FOIL. First, outside, inside, last, or you could think of double distribute, where I multiply this guy times here and here, and I multiply the 1 times here and here. Alright, so first step, let's multiply in. I'm going to multiply the square root of 3 minus 2p by both parts. When I multiply a radical by the exact same radical, it ends up becoming that whole thing squared. So like square root of x times square root x just becomes x, square root 4 times square root 4 just becomes 4, and so on and so forth. We will end up with no radical and just 3 minus 2p. That's the nice part of it. The not so nice part is the next part, when I multiply square root of 3 minus 2p by 1. So remember, it's innie, outie, outie, so it's a positive 1 and then square root 3 minus 2p. You don't really have to write the 1, I just like to. Makes it easier sometimes for people to see what's going on. Now I have to multiply the 1 by the square root 3 minus 2p, so again another plus 1, and then square root 3 minus 2p. And then the last thing I multiply is the 1 times the 1, which hopefully is 1. Alright, from there we need to clean it up some. So we're going to start to move things around, make this question look a little nicer. So I can combine and move terms to the left, so I have a 3, positive 1, I'm sorry, a 3 and a positive 1 here. That makes 4. I'm going to move the 4 on over, subtract 4 from negative 2, and it should give me negative 6 over here. Again, so it's this 1, this 3, subtract 4 over, makes negative 6. I also have a negative 2p that I'm going to add over. So when I add the 2p to the negative 6p, I get negative 4p equals. I now see that I can combine here and here. I have a 1 square root 3 minus 2p and another 1 square root 3 minus 2p. That can make a total of 2 of the square root 3 minus 2p. Okay, so I now have this problem, okay? I have the 2 next to it. I'd like to get the radical alone. Notice I only have 1 radical now. These questions are just tons of fun because they're super, super long. So I'm going to divide by 2. In doing so, that gets me negative 3 minus 2p equals the square root of 3 minus 2p. And now I just need to get rid of the square root. And we get rid of a square root, we know, by squaring. So these are really long, fun questions that people just tend to enjoy. If you make one simple mistake, absolutely nothing will work out for you, so be careful. The right-hand side becomes 3 minus 2p. The left-hand side we have to FOIL again. So those are minus signs in there. That didn't turn out very well. Okay, so we're going to double distribute again. Negative 3 multiplied by both parts is 9 plus 6p, and then we have to multiply negative 2p by both parts, which is another plus 6p, and then plus 4p squared. combine like terms. So I have a 6p. 6p is 12p. I'm going to bring over the 2p. So 6p, 6p, and 2p is going to make our 14p. I have a plus 4p squared. When I subtract the 3, that's going to become a 6. Equals 0. It's not quite written the right way, so I'm going to change it around. 4p squared plus 14p plus 6 equals 0. Looks like a tricky trinomial, but don't forget you can divide if there's a GCF, so I'm going to take the 2 out. Left with 2p plus 7p plus 3. All of a sudden this tricky trinomial just got a heck of a lot easier. It now has to be 2p and p, and it's either 1 and 3 or 3 and 1. I'm looking ahead, I'm thinking it's got to be the 1 and the 3. So when I multiply the 2 times the 3 I get 6, the 1 times p I get 7, 6 and 1 can make 7, I'm good to go. Okay, so what do the signs have to be? Both positive if it's going to multiply to positive 3 and add to positive 7p. We're almost done, sort of. We now have to solve, so we get 2p plus 1 equals 0, p plus 3 equals 0, so p equals negative 1/2, and p equals negative 3. Alright, so whenever we have fractions, decimals, and just some nastiness, I don't really care to do the check algebraically, so I have a graphic check here. Assuming this will start to work here. There we go. So graph 1 equation, right? It shifted to the right 2, and then it's got that whole negative thing, which is the reflection. Tons of fun. 6 times inside. Lots to do here. And then we have the other graph, which is 3 minus 2p. So in blue, here's the graph. You can see the point of intersection occurs right here, which is negative 3 comma 3. So negative 3 comma 3 is the ordered pair, which means, yep, it does happen at negative 3. That's our answer. You can kind of tell that those graphs, being square root curves, are not going to curve back and hit each other again. So that means this guy right here is the reject. At negative 1/2, you can clearly see, alright, oh, this should have been over here, sorry. At negative 1/2, you can see that they are not intersecting. Again, here is negative 1/2. They are clearly not intersecting, so the only answer is negative 3. Now it's checked. Question 2. More tons of fun. Alright, well, I don't really want to have, a negative and a radical all together when I have to square it. I don't want to have two radicals multiplied by each other. So I'm going to put one radical on one side, keep it on the other. So I'm going to move over the square root 4n plus 1 because I don't really want to have a negative radical, like I said. So I have the square root of 4n plus 1 minus 2 equaling the square root of 3 minus n. I'm going to have to square both sides. Okay. So we've got the radicals isolated as best possible. Really can't do much more, so we square now. The right side works out to be pretty well. Let's focus on that left side first. So 4n plus 1 minus 2 times 4 square root of 4n plus 1 minus 2. The right side just becomes 3 minus n, so that's the nice part. Now we got a FOIL. Okay, so when I multiply square root 4n plus 1 times square root 4n plus 1, okay, I end up with 4n plus 1. Square roots cancel. Now I have to multiply the square root of 4n plus 1 times the negative 2. Again, I have an innie with an outie, so really there's a 1 in front of this, so it's 1, the outie, times negative 2, the outie, and then we get negative 2 square root 4n plus 1. Okay, now we're going to multiply the negative 2 by both parts. So again, same idea, negative 2 times the square root of 4n plus 1, again is in outie times an innie, we can't do that. but there is a number 1 in front of this. This is also an outie, so it's going to be negative 2 times the 1 here, which is negative 2 square root 4n plus 1. And last, I multiply negative 2 times negative 2 and hope to get 4 equals 3 minus n. Okay. From there, I'm going to clean it up a little bit. So I see that I have a negative 2 square root 4n plus 1 and another negative 2 square root 4n plus 1, which I'm adding a negative 2x plus a negative 2x. That would be negative 4x. So I'm just going to write negative 4 of that whole square root 4n plus 1. I'm going to try and move everything else over to their side, see what happens. So I have a 4n. When I move that over, it should become a minus 5n. So I subtract the 4n over, I get a minus 5n. When I move over the 1 and the 4, so that's 5 that I'm moving over. When I subtract 5 from 3, I get negative 2. So in the last problem, we had it easy. We were able to divide, right, that number that was in front. We were able to divide that number that was in front. I believe it was a, what, negative, or it was a 2 last time. It's not this time, and I can't divide 4 and have a fraction over here. I don't want to have to square that. So I'm going to square both sides as is, because that is the game plan. Square both sides, solve it up. So when I square both sides, here is what happens. Okay. Now I'm always saying treat the radical like an x, so think of this problem. Imagine you had 4x, and you wanted to square it. It would be negative 4 squared and x squared, which is the exact same thing we're going to do here. So negative 4 squared, well, we know that. That's just going to become negative 4 times negative 4. Technically, I guess there should have been parentheses. We get positive 16. And then the square root times the square root. Well, anything multiplied by itself, right, with the square root, the radicals cancel, you end up with 4n plus 1. But you got to be careful, because you can't just write 4n plus 1 or times 4n plus 1, because it's 16 multiplied by the entire radical, which means I need parentheses around the whole thing. And that's going to equal, now I've got to square this side, so I actually have to do it out, negative 2 minus 5n multiplied by negative 2 minus 5n. So double distribute again, negative 2 multiplied into both parts, so that's going to give us 4 plus 10n, multiply in the negative 5n by both parts. That's going to give me another positive 10n and a positive 25n squared. That's not going to be a fun trinomial at the end. I'm going to multiply the 16 in and get 64n plus 16. And now I'm going to move things around and combine like terms. So I'm going to write equals 0. I'm going to move the 25n first. I'm going to combine 10n, 10n, which makes 20n, but then I have to subtract 64n from that to give me negative 44n. And then last but not least, I have to move over the 16, so I have to subtract 16 over. Yeah. From there, oh, I'm sorry, subtract 16 from the 4. That's wrong. That should be 12. 4 minus 16 is negative 12. Alright, so I need to now do the tricky trinomial, which is not going to be cool. So let's try the 5n and n and see how that works. So 5n, that's not good. My stylus just broke. 5n and n, 5n, I'm sorry. We'll try it with 4 and 3, and there's no need to switch it because it'll still be the same. That'd be 20 and 15. That's not going to work. Okay, we'll try it with 2 and 6. So that's 10n, that's 30n. That's not going to make 44. That didn't work. Okay, don't need to try 6 and 2 because again it's the same. So 1 and 12 That's not going to work. Guess what? It's not 5n and n. So I can just erase it. Sorry if you can't. It's going to be the weird one, 25n and n, unless, of course, I screwed up someplace. That would not be fun. So let's try the, I put the 2 here for the 12, and the 6 here. That looks like it could work. So this makes 6n. This outside one would make 50n. Yeah, and 50n and 6n could totally make negative 44n. So I have to have a negative and a positive here. So that gives me, the only way I can get the negative 50n is if I had a negative number here or here. So I'm going to change the sign obviously right here to make that negative. And then to have it be a positive 6n, I'd have to have a positive 6. We're not done yet. Need to do a little bit of work. Okay, so it still equals 0. I need to set each part equal to 0 to get answers. And then I'm going to have to do a check. So I'm going to get n equals negative 6 over 25. That is really awkward. And n equals 2. Again, I don't like to check these decimals. I mean, you totally could, and it's not really hard, to be honest. Plug it into the calculator. For some of you, that might actually be easier than graphing it. But you can do the negative 6 over 25 and negative 6 over 25. And if you are careful and you go slow and you type it in the calculator, you can just hit enter and see if it equals negative 2. That's a great way to check. And then you can plug in the 2 and do it. I'm going to do the graphical check just because I think it's usually a little bit easier. Here's my graph of y equals negative 2. The other graph, since it's got a square root curve minus a square root curve, is really kind of a really messed up curve. Messed up looking curve. It goes kind of like that. It's something you should take a look at in the calculator. Kind of curves back a little bit more like this. But anyways, the important point is the point of intersection, which is at 2, negative 2. So this value right here of 2 indicates that this guy is the reject and that this guy right here works. And you can also see that at negative 6 over 25, divide that out, you can figure out decimal, but right over here is where it is. Come on. Right over here is what you would get, and it's not obviously not crossing here. So the only answer is n equals 2. So that's the reject.